So let's say you found a skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey everybody, Dapper Dinosaur here. I am here with Doc Dino and Will Duffy. We are here to talk about dinosaur soft tissue and especially about the Mark Armitage horn that he found, and why it is that, generally speaking, the scientific community has not been super impressed with Mark's work because, at just a glance, it does seem like it would be pretty compelling. And so, yeah, we're going to take a look at that. I'm going to let people introduce themselves. We'll start with Will since I gave him bottom billing when I introduced everybody. Will, let everyone know who you are in case they don't know you, although I suspect most people here do.
Yeah, thanks so much. Will Duffy here. I kind of got in this whole scene of debunkers and creationists and evolutionists through creating the final experiment. So I had this idea to try to show something to flat earthers that would be convincing and came up with the idea of taking them to Antarctica. So we did that December of 2024. That was wildly successful, in my opinion. And so, anyway, a lot's happened since then. I'm now learning evolution from Erica, whose channel is Gutsick Gibbon. I have connected with a guy on YouTube named Grayson Hawk. He actually told me about Doc Dino. And so here we are. I'm really glad to have this conversation.
Yep. In fact, actually, not that long ago, Grayson and I went to go get Mexican food together when he was in my the town I live in, so which is Tucson, Arizona, in case anyone's wondering. That's public information.
That's
Um,
awesome.
yeah, it was a lot of fun.
That's
And we
fun.
talked, of course, about a lot of science and creationism stuff because that's how we're friends. And of course, Erica has been on this channel several times, and I've been on hers several times. So people here should also be very familiar with Erica. And if you're not, go subscribe. I also want to add that both the Final Experiment and Doc Dino's channel are in the description. I know that Will has said he's not really updating that channel much anymore, but there's still a lot of good stuff in the back catalog that you can go look at. And so, yeah, check that out. And Doc, who are you real quick? And then we're going to dive into your slideshow that we have here.
Sure. Well, howdy, folks. I'm Dr. Deinonychus, or Doc Dino for short. I've been on here a few times, but it has been a while. I'm a small-time science communicator here on YouTube, but I am hopefully going to go off to grad school sometime in the next few years to become an actual PhD paleontologist.
And you also
Until
done
then,
a bunch of
okay.
field paleontology, right?
I have done quite a bit of field paleontology, enough that my family was kind of worried about me for a bit. But I had fun.
Were you
And
out in the
I got
desert
to
for too
report a
long?
lot of fossils. Many times.
Yeah. At least you didn't do what my mom did, which was hang out in the desert in Phoenix and then for like an hour and a half just not have a sip of water and then have some heat stress problems. Or unless you did.
For the sake of my mother, I will say I never did that.
Oh, okay. All right. So Doc, I'm going to put your presentation on screen and we're going to start going through it. Now, everyone, I do know that I will be collecting super chats and stuff like that for questions later. There will be a Q&A. We're going to start with any questions that Will has after the presentation that he didn't bring up during it, if maybe he wanted to save it or anything. And then with that, we'll have questions from you guys. Keep them polite. This is not a time to ask Will your questions about like the logic of the Trinity or the historicity of like the Last Supper. That's off topic. I'm sure that there are other places that you can discuss that. Here we're here to talk about dinosaur soft tissue and things related to that. So like fossil formation, preservation, maybe age of the earth stuff like that. So yeah, if you ask a question that's off that topic, unless I feel like it's a really, really compelling question, I'll probably just read it and say thank you for the question, but it's off topic. That being said, I'm going to go ahead and bring this up. Here we go. Doc,
Alrighty.
go ahead.
Yes, I shall go ahead and get started. All right. So we're here to talk about Mark Armitage and dinosaur soft tissue, presented by me, Dr. Deinonychus, or Doc Dino for short. Here's a little flow through guide of where we're going to be going at with our presentation. Going to do some introductory stuff. We're going to look into the backstory behind why Armitage did his research, some problems I have with his paper, just general important information about fossils, creationist issues of paleontology, and then the Q&A. We're going to start kind of small and work up to a broader discussion because I like to do that. So, self-introductions and icebreakers. I'm Doc Dino. I'm a paleo student and I graduated with a BS in geology. I'm actually returning to school this fall for a teaching license because funding in my field is a little hard to come by right now, and most grad programs are strained.
Yeah.
I do have limited research experience, but I actually have extracted collagen from fossils before to perform some isotope analyses. I also do have 2 years' experience in the field searching for and reporting fossils in Wyoming, which, if you don't know, is just south of Montana. So basically the same place.
And then all my non-US audience members are like, well, I don't know where Montana is either.
Somewhere very high and dry. It is both lovely and hell on earth. Anyway, I'm very familiar with how to find and how to report fossils, as well as identify them in the field. And I also know a bit about what you're supposed to do with fossils after you find them. I also do have some experience with public science communication. This is when I volunteered with some kids at a museum, which was fun.
That is cool.
Will.
Oh, we already
I
did that. I'm
don't want
sorry.
to-
I ruined that part, didn't I?
Well,
My bad.
we can do a little bit,
Okay.
just so I'm not monologuing for 2 hours. Will, could you maybe tell us a bit about what you Armitage and his research, and maybe tell us what your favorite dinosaur is? It's a question I
Ooh.
always like to ask.
Sure. So I don't know much about Mark or his research. I actually didn't even know about it at all until Grayson Hawk brought it up. So I mentioned on Erica's channel that I have a friend who has recently published something in the field of soft tissue in dinosaurs that I was going to be talking to her about once I was able to, number one, get his permission, and number two, understand exactly what it is. So since I didn't say who it was, Grayson assumed it was Mark. So he emailed me and said, hey, if you're referring to Mark, you should know that Doc Dino has done some background kind of research into what he's doing and what he's done. And it's probably not a Triceratops horn. It's probably a bison horn. And so that was like the first information I was given about this guy. I then went to try to contact him and I can't contact him. His email bounces. I've reached out to people that I think know him and I haven't been able to reach them. So I really haven't looked into it much. I did have a conversation with Erica about it in person when she was in Denver. And she mentioned you as well before I had a chance to. And I was like, okay, I really got to connect with this guy and hear what's going on here. In terms of my favorite dinosaur, I'm not obsessed with dinosaurs enough to have a favorite one, unfortunately.
Will, I'm right here.
Really?
There's
Exactly.
like you just look up and you say, "Oh, it's the dapper dinosaur," and then we just move on. Come on, all
I
my
like
guests
that.
are always screwing that one up. Obviously, I'm your favorite.
I like that. I will say I am a bit obsessed with dinosaur soft tissue, though. So this really excites me that we're talking about this.
Well, I mean that's good. We're gonna spend a couple hours talking about it today, and
Cool.
I didn't expect both Grayson and Erica to bring me up. That's very flattering. I'm happy about that.
I will say that everyone in my audience who has said what their favorite dinosaur is has said a bird. So we have chickens, we have vultures, we have penguins. So,
I mean, they're free to do so.
oh yeah,
Uh,
I'm not disagreeing. I just think it's interesting given last night's stream with Erica where dinosaurs and birds came up. And I say
Yes.
came up like it wasn't planned as a big part of the whole stream. So, okay.
Right. I did want to ask you about that too, Will. Do you think birds are a category within dinosaurs, even if they didn't necessarily like evolve? Do you think they're just a part of the group dinosaur?
I do not know. I think if we start calling humans fish, birds dinosaurs, I feel like we're losing the purpose of language. So I feel like words have meaning, and the purpose of words having meaning is to distinguish them from other things. So I definitely do not think that birds are dinosaurs. That's silly to me.
Okay, I could go into a 2-hour diatribe about that, but we're here about a different one. But I do have
Okay.
thoughts.
Okay.
So if you want to have a different discussion on that topic someday, I'd love to do that.
Okay, sounds good.
I will simply say I disagree.
Okay. No
I actually only
problem.
kind of disagree. I also kind of agree.
I mean, if Stegosaurus and T-Rex are both dinosaurs, then so are birds.
But the thing is that words only have meanings in certain contexts, and in certain contexts, I think it's fine to distinguish between bird and dinosaur, and in other contexts, I don't think it is. So for the same reason that like we don't always call a tomato a fruit, even though biologically it's a fruit, I think it's fine if you have non-taxonomic reasons to say that birds aren't dinosaurs, while understanding that taxonomically they're within the group Dinosauria. I think that's fine.
Okay, fair enough. I guess I was thinking taxonomically when I asked.
See, I do too much linguistics, so I'm always hyper aware of things like that.
You're right. I should not have asked a linguist who is also a dinosaur nerd.
I'm not a linguist, everybody. I'm really not. Everyone says I'm a linguist. It's not true. It's horrible slander that was kind of started by Erica.
Yes, horrible slander. Well, anyway, moving on from the icebreaker. I do want to say just a quick little statement about the age of the Earth, quick, because obviously the age of the Earth is going to come up during this conversation. However, I believe that Mark Armitage's work on his Triceratops soft tissue is pretty faulty, regardless of how old you think the Earth is. Whether his fossils are 66 million, 40,000, or 4,000, I cannot talk. 66 million, 40,000, or 4,000 years old, I don't think he's done the necessary groundwork to prove their identity. And, Will, by the end of this conversation, we might still disagree about the age of the Earth. But I hope you'll understand why I, along with most of the paleontologists I've asked, am very skeptical about Armitage's findings. And kind of why young Earth creationists shouldn't really hold up his research as evidence of a young Earth.
Can I ask you a quick question?
Yes.
Do you find the other dinosaur soft tissue research faulty or just Mark's?
I find Mark's faulty in particular. I would have to, depending on the paper, like you're going to have some issues with any paper you come across if you read enough of them. I believe most of the work on dinosaur soft tissue is solid, but I have some pretty big problems with Mark's methodology.
Okay, and then last question is this. That must mean that whatever Mark's claiming would be a problem for an old Earth if it's correct, right? Because if it was the same as everybody else's and you don't have a problem with everybody else's, you just don't like how he did his work or came to his conclusions, you wouldn't really care, right?
I would care in that I care that science be done properly and that people not be misled about what counts as proper science. It's sort of like if someone were making an argument that I agree with, right? Like let's say someone's like, "Oh, I think evolution is true because it turns out that blue jays weigh less than 2 kilograms." I'm like, well, that's stupid. Sure, I agree that evolution is true, but not for that reason. Like, what difference does it make how much a blue jay weighs? And it's kind of similar with this, where regardless of the degree to which his findings are at odds with everyone else's, there are also problems with how the science was conducted that will be problems regardless of the outcome. And actually, I want to give an example. Brian Thomas is a young Earth creationist at Institute for Creation Research, and he actually just recently published a paper about finding soft tissue remains in a number of dinosaurs. And I haven't read the entire paper. I've glanced at it, and it has been reasonably well received by the paleontology community. And as far as I know, no one has any problems with any of the findings in that paper. So it's not that it's like, the young Earth creationists did a thing that we don't like. Like, no, Brian Thomas was able to publish that paper just fine. As far as I know, like I said, no issues from anyone. But Mark's paper is a bit different.
Yes.
Okay.
And I do want to add to what Dapper was saying. your methodology in, well, in science broadly, but in paleontology, your methodology is sometimes more important than your results. In fact, it can often be the case because a correct methodology, or sorry, because you can arrive at the wrong, wow, I can't talk. You can arrive at the right answer through incorrect methodology, but it'll be a fluke. If you don't do things right, then you can get false positives and false negatives and all kinds of stuff. And Armitage in his work has not done the necessary groundwork to rule out most of his things as false positives. It's just a lot of it is very shaky.
How is it getting past peer review?
Mostly because he published it in a journal that was a journal about microscopy and not paleontology. And I'm sure that his microscope work is spot on because he's a professional microscopist who's run a microscopy lab for a very long time. So it would not have passed peer review if he had published it in a paleontology or a biology journal, most likely. Certainly not in a paleontology journal, because as we'll go through, it doesn't meet the minimum requirements for a paleontology paper to pass peer review in several ways. But
yes,
when you give it to
publish this, and if he tried to publish this in like biology, for example, or PLOS One, it would get thrown back for peer review, or it would get thrown back for redrafts multiple times.
Yeah, it's possible that eventually it could pass, but in the current state, it certainly couldn't.
Okay. And then, sorry, real quick, just because it helps me to know kind of where we're going. Are you guys saying that if his conclusions are true, that is not a problem at all for an old Earth if he fixes everything and gets it published in PLOS One?
I would say that if his conclusions were to stand up, which is itself a bit of a question, but let's assume that everything he did was on the up and up and he'd met all the requirements to actually publish this, I would say it would certainly be a problem that would be currently unsolved. I don't know if the solution would necessarily require that the Earth be younger, but it would certainly present something that is so far unaccounted for.
Okay, that excites me. So let's continue.
And I would say it's also kind of a mixed bag. Some of his claims are very mundane, while others are very much the opposite. So it's a mixed bag. And
yeah.
Also,
some of his claims would actually, if you took the young Earth interpretation, would say like, well, then the Earth is probably like 100 years old, Mark. That doesn't really add up. Like he said in interviews, not in the paper, but in interviews, he said that he thought that some of the cells he found were living cells that he could culture, which that would require the bone to be like fresh, like it died very recently.
Days to weeks old fresh at most.
Yeah. So I don't even know how he's managing to fit that within a young Earth creationist time frame, because we're not talking about like, oh, well, it was buried 4,000 years ago. We're talking like it came off the like slaughterhouse line recent, like just now, and now sure you can find some bone cells to culture, but otherwise no, you can't just have a bone cell be alive in an animal for 1,000 years. But that's not in his paper, so like it is a bit off topic because technically he's only said that in casual conversation in interviews, which is not the same thing as what you put in your published stuff, which is a big thing to remember because a lot of scientists say a lot of crazy stuff in interviews that they will not put in their peer-reviewed papers.
Yes, that's true. And we will be going into some outside media for this because it gives greater context. But part of that is because he did not give the necessary context in his paper, which is a big problem in paleontology. Because you can find a bone anywhere. If you don't know where that bone came from, it tells you that you have a bone.
Yep.
You can't do anything with it. That's why the private fossil trade is honestly horrible for my field. Most paleontologists hate private collectors because they never keep good notes. Anyway, so statement by the age of the Earth. And we're going to go into a little bit of background because Armitage did not do his work out of the blue. He was inspired by prior workers, which is pretty common in most fields. So, starting in the 1990s, Dr. Mary Schweitzer began to discover these weird artifacts and the remains of some Cretaceous dinosaurs. Fragments of what later turned out to be proteins, amino acids, and some other original biomolecules in fossil remains. Those discoveries challenged a lot of preconceptions that paleontologists had about the process of fossilization and preservation in general. It it was revolutionary. Like, make no mistake, it was a big deal. And her work made headlines across the world. In fact, her research has inspired a completely new subfield within paleontology. And even today, Dr. Schweitzer is pioneering new methods in paleomicroscopy and analysis of preserved biomolecules. It's a really interesting little subfield she created. And because, well, inspired by her work, in 2012, Mark Armitage, Kevin Anderson, and some of their colleagues excavated a large horn, ribs, and some vertebrae from several sites in an area near Glendive, Montana, which I've actually been to. I wasn't able to see the site myself, but I got very close, and I couldn't go to it because it was on private land, and you don't go on private land in Montana if you want to come out in one piece. But after preparing those specimens, Armitage and Anderson discovered what they claimed to be sheets, like literal sheets of soft tissue and osteocytes preserved in the bone. Their research was published in 2013, and they claimed that these soft tissue elements were found in the remains of a Triceratops. Subsequent research on these bones and others discovered at the same sites have yielded blood and nerve cells, as well as a lot of organic matter. And I will note, Dr. Anderson passed a few years ago, but Armitage is still pretty active in young Earth creationist circles. We'll largely be discussing the work of Armitage since he is still publishing, but Dr. Kevin Anderson was involved, at least at the beginning.
Yeah, and as far as I know, he hasn't like retracted anything that he did with. He never retracted anything he did with Marcus. So everything that they did together, as far as I know, he always stood by. Even though they did have a little bit of a personal falling out and stopped working together, as far as I know, he never then went on to say, and all the work I did with him was crap. Like, he stood by all of it, as far as I can tell.
Yeah. So a little bit of background there. So there's the background of the paper, why they decided to embark on this research journey, and some of the stuff they found. Now let's take a closer look at the content of the paper. The 2013 paper that inspired this big wave of young Earth creationist fervor regarding dinosaur soft tissue. Now, according to their paper, the horn was discovered somewhere in this orange rectangle, located to the southeast of the town of Glendive, Montana. The ribs and vertebrae were discovered within a mile of the horn, which is illustrated by this red circle. And in order to find this area, I had to parse their surveying notation they used to describe the site. And
it
is
very
written,
confusing. Doc and I spent days trying to figure out what the heck this meant.
Yes, this is verbatim from the paper. A portion of land located at east half of the southwest quarter of the northeast quarter, section 14, T15N, R56E, Dawson County, Glendive, Montana, USA. Most people just give you GPS coordinates, even in 2013. Or if not GPS coordinates, they will literally draw a map, as you'll see on the next page. I brought a comparison example.
And usually give latitude, longitude, often down to the arcsecond.
Yes. This is very imprecise and very weird. In 2013, it might have slid by in some paleo journals, but not most.
I've never seen anything that vague in a paleontology paper in the last, 50 years.
I said might.
Might, yeah.
Now, just to be clear, are you guys contesting that this is the right location where he found the horn?
No, I believe that he's being honest about it. It's just that it's sort of like if I told you I had found the cup that Jesus used at the Last Supper when he was instituting the Lord's Supper, and you said where, and I was like Jerusalem, you'd be like, yeah, okay, but like where, right? And that's kind of what's happening. Maybe I'm being honest
Sure.
about Jerusalem, but like just me saying I found it in Jerusalem, you need more than that. Like, why do I think it's the cup? And usually, I'm making a comparison to archaeology intentionally because it's the same kind of thing that happens in archaeology, right? In both cases, we need to know where something was found so that other people can go and check and see, like, okay, is this actually a place that like could actually have first century artifacts, or was this actually a location that was built in like the 8th century by Byzantine Romans, or is it or yeah, okay. Or was it like built in like the 12th century by like one of the various sultanates or something? And
Okay, so I'm just speculating here because I can
Mhm.
think of hypothetical reasons why you wouldn't want to give the exact location. So for example, if somebody found something famous on my property, I would not want random people like Doc, you said you went to Glendive. I don't want random people coming on my property.
well, there are a couple things there. One, uh, this is Bice Ranch, which actually runs a for-profit like touristy dinosaur dig thing where you can just pay to go dig up dinosaurs. So in terms of that, and I've actually talked to one of the landowners here. I talked to Shauna Beisch, who is
Mm.
the wife of the guy whose name escapes me, but they own this ranch together, and she is open to basically anyone who pays and isn't like obviously dangerous. In fact, she invited me to the ranch. I haven't been able to get out there, but the other problem is that if you're doing a scientific or an archaeological study and we can't figure out where it's from, then it's pretty much useless, regardless of the fact that you don't want to show people exactly where it's from for personal security reasons, which are fine. But
Mm.
if you
Mhm.
don't want to do that, then people in those fields will generally not take your claim seriously. Which is why that's one of the reasons that we can distinguish between things like treasure hunters versus paleontologists or archaeologists is because of that openness that is key to science. Because without that openness, we get into situations like you probably remember cold fusion, right? Where no one could really replicate it at all. But the guys were like, "Don't worry, we got this." It's like, well, they ended up not having it. But the reason there was some hype was because they were able to basically keep people from being able to try to really seriously replicate it for a while. And that's the same kind of thing. We also have this with other archaeological things. We have other archaeological frauds that have occurred. Like one thing that I think is rather amusing is someone tried to convince some people that he had found Noah's Ark by aging some wood in teriyaki sauce, and they believed it. Now, granted, this was not a majority of like, the Christian community. Most people were like, I don't think you did. But there were articles published on the teriyaki soaked ark. And so
Mm.
like there are
Mm.
there are people who in bad faith try to go about this, and the way that we prevent it is by saying regardless of whether or not you're in good faith or bad faith, we need to know exactly where you found this such that if I have permission to be there, which you can get from the Baishes, then I can
Mhm.
go to the exact location and know where it is and know what the context is.
Okay, so real
Yeah.
quick, if he gave the exact location, the horn is gone. So when you get there, there'll just be dirt. How does that help you?
So
Because
that's not always the case. I've done this before because I've actually gone to already excavated sites. It is very common for new material to come out of old dig sites because you
Mhm.
can only dig so far into a hillside in a given year. So
Mhm.
it's very common for there to be stuff that's just inches beneath the surface that washes out the next summer.
yep.
So it is
Okay,
very
so
common for people to go back to already excavated sites, see if new material is there, because if there's new material, you can publish on it.
okay, I'm not disagreeing that there's new material, but I highly doubt every paper on a dinosaur find required someone else, a third party, to go and dig around and find new material. That seems absurd to me.
That's not what's being claimed. What's being claimed is that the exact location needs to be provided such that anyone could go to the dig site to check on things like did you did you correctly identify the geological context? Also, to check, can I find something else? That needs to be an option because that's a big part of the replicability of the paper. And replicability is separate from being replicated. You, generally speaking, to be published, replicability must be at least in principle possible. But it doesn't mean that someone has to actually have gone to do it before you can publish.
Yes.
And that's a big part of science, because the first time someone does something, obviously no one has replicated it, and obviously we want to know about it.
Mm-hmm.
But in order for us to say that this is something that we should consider, you have to leave open the possibility that another person is going to be able to find results that are similar, replicating your process. And part of that in archaeology and in paleontology is being very specific about where you found everything that you found.
Yes. And for the record, while this orange square might look tiny on this map, this is about 100,000 square feet, just out in the middle of the Montana Badlands. And the bigger deal right here is that the ribs and vertebrae were found within a mile of the horn.
Mm-hmm.
You might as well not give any location information because that tells us nothing. Those other bits of Triceratops remains could have come from anywhere within this red circle.
Which is about, what, like 6.5 square miles?
Yeah, 1 mile times 2 pi.
Yeah.
Sorry, are you guys saying that if something's found a mile away, it's not relevant?
It's not that it's not relevant.
Well-
It's that it's hard to figure out what the context is and also determine whether or not it's relevant. It might be relevant, but it also might not. So, for instance, if you found a horn in some Cretaceous sandstone, but then later you found a rib fragment in some like Pleistocene river deposits, those probably aren't from the same animal. And without knowing exactly where you found them, we're going to have trouble figuring out if you actually did find them in a place where it could reasonably be connected. And that's one of the problems, is we don't know the degree to which we can associate any of the vertebra or the rib that Mark found with the horn. They might be associated. I don't know. That's the problem, is I don't know. I can't say anything about it.
Okay,
like we have no location data for the ribs or for the vertebrae, like at all. We do not know if they are related, if they could be related. They're going by old Earth dating methods. There is a range of about 80 million years in the strata in this little circle. So precise location is very important.
Mm-hmm.
And he does not give us that information.
I do want to say one thing, which is that I care more about truth than I do about rules, if that makes sense. So, hypothetically speaking, again, because I don't know these people, but if these people on this ranch are like, hey, we're not allowing anybody on the ranch, okay? According to what Dapper just said, that now nullifies this science from peer reviewed journals. Is that right?
It does not nullify
Not
it.
necessarily.
That's what he
but-
said. He said if it's not accessible to be repeatable, it can't be published.
So there is more than one way to repeat or double check on something like that. So, for instance, if it were given a precise site location, we could check previous reports from the same location to see if it actually matches up with what he's reporting. So, for instance, if he gave a precise site location and what was previously reported there was like something that just normally is never found with Triceratops, like if we found a bunch of Stegosaurus, which are just never found with Triceratops in the same layers, we'd say, okay, this is iffy. Conversely, if what he found there were a bunch of like American cheetah fossils, which is an extinct cat that used to live in North America, the American cheetah, that would also be iffy because we never find those. That's not to say it's impossible, but we would say, okay, we have to put pause on this until someone else can actually figure out what's going on, which could just be the person looking through the old data, because maybe we're wrong about the fact that Triceratops and cheetahs have never been found together. Maybe we'll find that there is actually compelling evidence. We haven't yet, but maybe. But
I mean, like,
the
even
other
if
thing
you-
is, sorry,
Go.
the reason that
Sorry,
science
you
has
finish up.
the reason that science has rules is because in the past it didn't, and we learned the hard way that without having ways to check on things, ways to verify that what people are saying is accurate, incorrect stuff slips through, right? Like that was one of the problems that happened with Piltdown Man, which is a hoax I'm sure you're familiar with. It
Very.
was just found in a gravel pit, which doesn't make a whole lot of sense, but like we hadn't really established all of our current conventions and no one super cared about that. And so people just went with it. Whereas if we had had actual like hard and fast rules saying, look, you need to show us where you found something, you need to tell us what the geological context is, we need to know how this came into your possession, into your museum, whatever. If we had done that, then Piltdown Man probably would never have gained any prominence, although its prominence did wane before it was disproven. But yeah, we would have avoided that entirely. And that happens with a lot of things, right? Where we find out that, oh, hey, we've had this problem with either misinterpretation or bad faith actors or something, and here's how we can fix that going forward while still allowing all of the science to be done. So that's why we have, like in physics, right? We say, oh, you need to detect, if you want to say that you found a new particle in a particle accelerator, your detection has to be of a certain level of statistical significance. And usually it's said to be like, I think was it like 5 sigma? Is that the rule for physics? I don't remember. Doesn't matter. It's some level of statistical significance. And below that, what you say is you have a potential find. And until it's at that level, we say it's not confirmed because physics has been burned by that before. People have thought they found something, and it turns out, no, what you found was that your instrument has an error, or you found out that there was random noise in your sample that you thought was signal instead of noise. And that's why we have these rules, is to prevent these false positives from popping up because they have. And so it's true. You might be right while violating the rules, but until you can show that you violated the rules is reason for people to say, well, I don't know.
That's fair.
And maybe to put it this way, you care about truth, Will. I am not calling Armitage a liar with this publication, with this information, but I have no way to verify if anything he says about these bones' location is true. So I cannot tell if he is telling the truth or if he is lying with this information.
I personally don't think he's lying. Like, I would be very surprised if I found out that he was intentionally saying things he did not believe to be true. That would shock me. Because he doesn't strike me as someone who is likely to do that about this find. I think, and also I want to say, like I said, I talked to Shauna Beisch. She agrees about Armitage's main claims that this is a Triceratops horn and that he found it on her property. I believe, if I remember correctly, she said she wasn't exactly sure if she could find the location again because it's been a while, which, I mean, fair enough, right? She wasn't in charge of that. And also, she seemed like a very nice lady when I talked to her on the phone. And it's one of the very few times I've ever called someone on the phone for research purposes for this channel. So thank you, Shauna, for being lovely to me on the phone. I really do appreciate it. If you ever happen to watch this, which I doubt.
Yeah, just all this to say, this is not good documentation here. And documentation in paleontology, very important, as in most fields. Which brings up, well, the issue we've been talking about.
Yep.
Where exactly are the sites that these bones are being pulled out of? We have the horn down to about 100,000 square foot rectangle, as measured on Google Earth. Most modern publications will give precise GPS coordinates for their quarries or high-quality maps at different scales. We would also expect to see drawn or photographed site maps, neither of which are in Armitage's paper. Sorry, Armitage and Anderson's paper. Just not giving the location for the ribs and vertebrae is also strange too. Most publications would give individual locations for each find or quarry, especially if they're disconnected. And just as a comparison to this, so this is the location information as given in Armitage and Anderson's paper. This is a map given from a more normal paleontology publication. This comes from a description of a new sauropod by Emmanuel Schaap and Octavio Mateus from 2017, the sauropod Gallium from Wyoming. And I chose this paper because I've been to this exact quarry. I got a tour of it by the owners. And I've also met Emmanuel Schaap. Very nice guy. It's also noteworthy that this publication doesn't just include a map to where the bones were found. It also gives a stratigraphic column for the exact rock layer that Gallium was discovered in. Neither of these things are in Armitage's publication. So if you've never seen one of these before, I don't blame you. This is called stratigraphic column. It tells you what rock types are found at what elevations relative to each other. It's kind of hard to see in the presentation, I know, because I can't zoom in. But it goes like foot by foot for thickness. And it goes through stuff like sandstone, mudstone, tells you what fossils were found at what elevations, all the important details to find exactly where this fossil was found between these two maps.
And I want to point
There
out
is no
that
equivalent for Armitage's paper.
stratigraphy maps like this are not based on a hypothetical or theoretical column. These are just what is physically found by people digging through the rock, just put in a graph. So this is not like, well, we know from our stratigraphic column that we learned in, geology school. This is just like, okay, I found this many inches or centimeters or whatever of sandstone. I write it down. And then I make the picture for the paper based on my notes about exactly what I found when I was digging.
I had to make dozens of these when
Yep.
I went to geology field camp in college.
They're really important for anything in geology because it's not just how you find like fossils or how you orient yourself in terms of like the fossil record, but it's also important for things like mineral exploration, oil exploration, coal exploration, natural gas. All of these stuff require you to know where you are in the local column. So they're actually one of the routine things that every geologist does. In fact, even some of the young Earth geologists like Andrew Snelling has published some of these, which, I mean, as far as I can tell, he did perfectly good work on those. Because if he didn't, the mineral exploration company he was working for wouldn't have paid him because he wouldn't have found the minerals they were looking for.
Yeah. And again, this is stuff that's normal in paleontology publications. This is stuff you see all the time in journals about fossils. There is no equivalent in Armitage's paper. And granted, it is focused on the microscopy, but there's not even like supplemental materials that you can go through to get this information, which is, again, very important information that's just not there. Also, just a little anecdote here. This red line here is a road that goes to the quarries. This road is terrible. I hated driving on it.
My condolences.
Anyway. Oh, my car almost died.
Yikes.
So, continuing this issue, where are the sites? And this is expanding on our previous discussion of where the sites are, because we didn't get pictures of the dig sites in the publication, but they did come out after, because Armitage and Anderson both did interviews about their findings. These pictures in particular are going to be coming from an interview Anderson did for the documentary Is Genesis History? Oh, and sorry, we do have one site picture for the actual paper. It's a black and white photo of the horn sitting in the dirt. There's no context given beyond that.
Hold on real quick. You're saying there's only one black and white picture in his paper?
Of the horn as found in the ground. There are other pictures in the paper of him holding things or of the horn at the lab after it's been fractured into pieces, but there is only one picture of the horn as it was found.
Yes.
Okay, and it's black, and you're saying it's black and white? Like I feel like Eric has
is.
sent me a color picture.
He has a color picture that he didn't put in the paper. I think the
Yes.
publication itself might not actually support color photos. I'm not sure. But the color version of that has been circulating for a while. It was in at least a few different videos where he's given interviews where I think he gave that to people. So that picture as a color version is available, but it wasn't the version of it that was in the paper.
Yes, and that is something you would want to include in the paper. And even if it was in black and white in the paper, you'd at least want it to be high quality. Dapper, will your layout freak out if I switch what tab I'm sharing?
I don't think so, but I don't know. Maybe.
Okay, let's see how this goes.
Nope, seems fine.
Okay.
Yeah, this is the actual paper.
The actual paper downloaded from ResearchGate. This is the picture of the horn in position, as seen on the page. Here's a photo of one of the ribs. And then here are chunks at varying levels of magnification from the laboratory. This is the quality of the picture. It is not very good, and there is no surrounding context is the big issue.
Yeah, from this picture,
Or
even from the color version, it's hard to tell
Yeah.
what rock that is, where it would be located, and things like that, which is the kind of thing that we would like to know.
Yeah.
Hmm.
Or
'Cause
even if it is rock or just like compacted sediments, which is something else it could be.
right. Which actually, like, here's one of the things. I'm not primarily interested in this find because I'm like, oh, Mark Armitage bad. I think it would be really interesting if this is a Triceratops find that has the microscope pictures that he showed us, that it came from that, right? That would be really interesting to me, and I would want to know more. But I can't. And on its own, just that fact bugs me, because normally that's not something I come across in paleontology. If I wanted to know more, I could just find more, but I can't. And I hate that. And that's one of the reasons why I started being interested in this in the first place. And then after that, it started to dawn on me that, like, okay, there are irregularities here. Not necessarily irregularities in the sense that, like, Mark is saying something that he thinks isn't true, which would be, him lying. I don't think he is, like I said. But it just kept getting weirder and weirder the more I looked into it.
Yeah. And especially when you compare it to contemporary publications, even other paleontology oriented microscopy publications usually include either they include some or all of this information, or they give you a specific specimen number that is housed somewhere you can check it out and get all the information for.
Yeah. That's usually for something that someone else has dug up, and the original publication usually would have had that information, but now it's sitting in a drawer somewhere in a museum.
Yeah, like a lot of Mary Schweitzer's work has been on two T-Rexes housed at the Museum of the Rockies, MOR 555 and MOR 1125. You can find all of the information for those specimens online, like all of it.
Yeah.
We cannot find anything other than a blurry rectangle for this, and then a circle.
Okay. Man, it's so hard, guys. I feel like I don't want to blame you guys, but I feel like you're nitpicking this because it's Mark and also not taking into consideration other factors like funding. I feel bad for Mark because if you guys, I mean, Doc, you mentioned something about finances at the beginning of this. If you found something and you did the best you could with the funds that you had and people were treating you like this, you'd feel terrible.
So what I
I mean,
would
a
say to
GPS
that
is cheap, though.
is putting in a site map and a stratigraphic column costs an afternoon.
Yeah. And
It costs one afternoon for one person to do, and I say that with confidence because I have done it
yeah,
multiple times.
and in
It's
2013,
easy.
getting GPS coordinates is just looking at your phone. I would
Or
be very
taking a picture of the site with your cell phone you always have with you costs nothing.
yeah,
Even a flip phone.
and when you say nitpicking, one of the things that we have to recognize is this is the first step in paleontology, is making sure you know and other people know what the context is for your find, because without that, we don't have anything. In fact, there have been papers recently published on dinosaurs where the first step was spending actually a lot of time figuring out where it came from, because the problem was that it had been collected by a private individual who did not give the context. And so people had to sit there and say, okay, what are the microfossils? What is the exact lithology of this rock? And how can I connect it to a location most recently, I'm thinking about something in China, because a lot of really cool fossils are coming out of China, but unfortunately, a lot of them are being dug up, I guess, I don't know, dug, yeah, by just locals, and then they're being sold. And the problem is, if you want to study one of those, you basically can't until after you've been able to assure everyone that you know with pretty high precision exactly where you found that, or where it was originally found. And that takes a lot of work. But for Mark, or for anyone else just going to Bice Ranch, right, what it takes is taking your phone out and checking your GPS, and then just putting it down in your notebook. And if you're not carrying a notebook, you're not doing science.
Okay, so guys, I'm really disappointed, unfortunately. Something I learned with the final experiment is that there are things that don't make sense, and the best thing to do is to contact the person and ask them why. And I'm going to give a perfect example that should resonate with everybody here. There was a literal edited video of the 24-hour sun in Antarctica. It had duplicated clouds. The flat earthers discovered it. No one knew why. We could not come up with a reason, and the flat earthers cried victory. And I got mad at the flat earthers because I'm like, which one of you ever made a single effort to just ask the guy who filmed it why the clouds are duplicated? And guess what? None of them did. I sent one email to Anthony Powell, made communication with him, asked him, and he gave me a perfectly valid explanation that I
Yeah.
could have never come up with on my own. So not having GPS coordinates in 2013 is guys, there might be a perfectly good reason. You're majoring on a minor here. I got excited for this conversation because I want to do something that's going to make progress. If this entire conversation is going to be, Will, we actually think that Mark found a Triceratops horn. We think that that he's not lying. We just don't like his work. This is a huge waste of my time.
It's not, but this is fundamental to paleontology. And
Okay,
also,
but guys, this is a huge waste of my time. This could be solved in 5 minutes. I'm not going to sit here for an hour listening to you guys say we can't believe he didn't use his cell phone in 2013 to come up with GPS coordinates. Guys, what if he didn't have a cell phone in 2013? What if he didn't have a cell phone with him on the dig site? What if he didn't think about it because he was so excited that he found a Triceratops horn? All I'm trying to say is I could speculate 1,000 reasons why he didn't include the GPS coordinates. If you guys want to make a point that's worth my time, such as, Will, Mark didn't include the GPS coordinates because he's a fraud and because this isn't a Triceratops horn, that excites me because then I can go try to find Mark and get to the bottom of this and be like, Mark, are you a fraud? But just talking about this is a massive waste of my time if you actually think he found it where his picture says he found it. I don't care about GPS coordinates, guys, unless there's a reason. Tell me, make this worth my time, please.
well, do you want
This is a
to
massive
do
waste
you
of
want to
time.
presentation,
Okay.
Dapper?
Doc, do you want to skip to the identification of the horn because we also have slides on that?
Well, we can get to that.
Well, let's go ahead.
So first, just pictures of the horn, where it is. So, okay. You were asking if, I don't know, maybe it wasn't found at the place he says it was?
Let's keep going. We'll
Well-
just accept that it was where he found it was. Come on.
Okay, might come back to this. Okay. So, oh, well, that's misnumbered. So, wait, did I go? Okay. Okay. So, problem with this paper, what exactly are these remains? Because Armitage and Anderson say they are Triceratops. And for confirmation for that, we have a photo of a rib and 2 photos of the horn, one of which is from a post from the Creation Research Society, not from the publication. That's the second picture here. So the reason why we were harping on the provenance, where the fossils are from, is because without a solid understanding of that, we have to compare what we have, its gross morphology, to known animals in the region. In comparing these fossils to other fossils known from this area, we have 2 possibilities. This is either 1, a Triceratops horn, or 2, a bison horn, specifically bison latifrons or the Ice Age longhorn bison. Of these choices, one of them seems more likely and would have a greater likelihood of soft tissue preservation. So, let's look at our possibilities. Let's compare them. We have bison latifrons, which lived during the Ice Age and is found throughout North America. It might be ancestral to the modern American bison, but was on average much larger, with horns that could easily grow over 1 meter in length.
And also,
Go ahead.
I do want to point out that a known bison latifrons has been found a few miles away from Bison Ranch. So we know that in the area, generally speaking, where this dig happened, bison latifrons do occur. So we can't ignore that possibility for reasons of knowing where, like being in the wrong place. Like if Mark had said like, well, I dug this up in Africa, like, well, it's certainly not bison latifrons then. But this is part of the reason why knowing is important, because we can be very specific about where we can find bison latifrons horns, but we can't tell if Mark found that for that reason, without the specificity, which is why it's important. But for gross morphology, yeah, we'll just continue on with that. Sorry about that, Doc.
It's okay. I do want to say that this is a 3D model available for free on Sketchfab that anyone can look
like
around
Sketchfab.
at. Yeah, Sketchfab's great. And our other
Sorry.
possibility,
Sorry.
we have.
Do
Go ahead.
we, if we found one of these, what are they called?
The bison?
Bison latifrons.
Yeah.
If we
Latifrons, yeah.
found one, is there a picture of one, of the one that we found?
I mean, there
In-
are hundreds of them as far as I know,
Okay.
but most of them tend to be just a skull.
yeah.
Because that's what preserves best. So this is a composite of the fossil material that we found that has been put into a full skeleton, much like a lot of the times, like over on the right, that Triceratops wasn't found in that condition articulated. And so not all the bones were found, but we have found those bones in other Triceratops generally. And so, like, most museum displays that you see are composed of, like, the bones from a few different members of the same species. And some of them are plaster replicas for purposes of weight. Although, maybe I'm wrong about this particular display, because Doc Deino seems to object.
Yeah, I was going to say, this is the skeleton of Hatcher, a pretty famous Triceratops. I think it's fairly complete, though I could be wrong. But something to consider here is we have hundreds of both of these animals. For whatever reason, Triceratops is wildly common in Cretaceous rocks. It's just everywhere. We have literally hundreds of skeletons. Same for bison latifrons from all across the USA. Hundreds of these guys. And a lot of them are fairly complete. Like at least 50% complete. So anyway, that was bison latifrons. For Triceratops, lived during late Cretaceous in North America, known from hundreds of skeletons divided between two species. Their horn cores could also grow up to 1 meter in length. In some cases, though most were shorter. So let's take a closer look at each of our possibilities. Here is bison latifrons. As with many horned animals, bison latifrons does exhibit considerable variation in horn shape. But the horn cores are generally long and curled upward from the skull. When in good condition, you can also often see these grooves that run along the length of the horn. And they can go the entire length of the horn, but it depends on how well the surface is preserved.
I will point out when Mark was asked about this possibility, his response was it couldn't have been a bison horn because bison horns don't have a bone core. That is very incorrect.
That's what Mark said?
That is what Mark said. I was there in the live stream.
I was not aware of this.
Yep. He said it in an interview with SFT. I was there for the live stream.
Guys, real quick, what is a bison latifron's horn made of? What is a Triceratops horn made of?
They're actually both made of roughly the same stuff, which is interesting because there's a bone core, and then on top of that is some living tissue that itself is sort of like the cuticle for like a nail or a claw that then grows keratin on top of it. And so both mammal horns and ceratopsian horns have very similar structures in terms of what they're actually made of. They have the bone, living tissue, then keratin. And keratin is the same stuff your fingernails are made of.
Are you saying we can't tell the difference in a lab?
We can if we have very good specimens or we have enough data about where they're from. And we actually have, in the upcoming slides, some reasons to say that the bones that Mark found are more consistent with bison latifrons morphologically, but it is difficult to tell, and some horns have been mistaken between the two historically. Like some of the first...
The holotype of Triceratops actually was mistaken for bison latifrons.
Yep, so the very first Triceratops to be described, that is sort of the thing that says what a Triceratops is, that's what a holotype is. Originally, that was said, oh, well, we found bison horns. And then we came back, I didn't do it, obviously. Other people came back later and were like, no, this is a dinosaur, actually.
Yeah.
Okay, so just so you guys know where my mind is thinking,
this is
I'm just trying to figure out how to get to the bottom of this. That's where my mind is spinning right now. I'm just like, well, if we just need to go get the specimen from Mark, and we need to go get a specimen of bison latifrons, and do a test, then let's do that.
That's a problem. The specimen from Mark doesn't actually exist as a horn anymore. He broke it up. It was accidentally broken on the site, and then it was later further intentionally broken up to do the tests. So the horn doesn't exist anymore. So all we have are Mark's published photos.
So hold on. Why do you are you saying you have from Mark that none of it exists anymore?
Not necessarily none of it, but it's been broken
Okay.
up into small pieces, and we
All,
would
all
need
we need is a microscopic piece to
no.
if we can tell the difference.
You would need more than a microscopic piece. You would need a considerable amount of the horn, especially when these horns are very similar in structure.
Yeah. Okay.
How do I put this? For any given bone, there can be diagnostic features that can tell you what exactly it came from, like mammal versus dinosaur or horse versus cow. There can be diagnostic features, but if those have been worn away or destroyed in an acid bath, you can't identify just a crumb of bone.
Even with a
You
microscope.
can't. Unless you can get DNA from it, but that'd be a long shot with a bison latifrons, let alone a Triceratops.
Okay, we can keep going.
Okay. Good questions, though. And yeah, here's the structure of a horn. There's a bony core and then a layer of keratin on top. That's what actually stabs things. So what you're seeing here are the horn cores. And they have these kind of striations on them that you can see fairly well in this picture. They follow the length of the horn. They help guide its growth. Now, notably, with bison latifrons, one of their diagnostic features is that the bone or the horn doesn't begin at like flat against the skull. There's an outgrowth from the frontal bones that you can see here. They kind of bulge out and then the horn grows.
Like in the
That's
lower
what they-
right?
Yeah, in the
You
lower
can
right,
see that
you
in
can
the
see
lower
that.
right too, yeah.
Got it.
But here's a modern bison skull that I got that's just more complete for visualization. There's a gap, and then the horn starts. For Triceratops horns, there is a bit of variation, and that's partly because there are two species of Triceratops. Triceratops horridus usually has larger horns that swoop, they recurve because of how they grew, or they can be more straight because, again, variation, but they're usually recurved. And those can be between about 0.6 and 0.8 meters, typically, sometimes up to 1, but that's very rare. For Triceratops prorsus, they usually had smaller brow horns that were more curved. We're talking about 0.5 meter to 3/4. But for both species, their brow horns are direct outgrowths of the supraorbital bone, which forms above the rear of the eye socket. You can see that here. It's basically right above the eye. There's no out-pocketing and then growth, it's just horn. They also don't usually have those very long marks that you see on bison horns.
Yeah. They do usually have grooves if you have a really good Triceratops horn, but they're form more like a branching pattern than they do like grooves that go along the horn. And I've actually seen some of the nice branching patterns in person. Last time I was in Colorado, you probably know that I don't remember the exact name of the museum, but it's outside Denver. It's like a natural history museum. They've got a big elephant statue out front. They have their fossil preparation room is actually something you can go look at. And there's actually some windows where you can talk to the fossil preparators. And I was there with one of my little nieces, and she tried to grab a hold of a Triceratops horn. And I'm like, nope, let's not touch the fossil. So it was a lot of fun.
But so we've taken a look at these horns individually. Now let's compare them to what we have. Because as we've talked about, all we have are pictures at this point. And this is the most complete picture we have. Which is not the one from the publication. This is from a completely different angle after they exposed more of the base. This is from the Creation Research Society. So while it is hard to ID fossils from pictures alone, I do personally lean more towards this being a bison latifrons horn because of 4 different factors. One is just its size. It's kind of hard to see in these images, but this horn is big. It's at least 34 inches long. It's at least 34 inches long, and I say that because the tip is still buried in the ground, And I don't know where it ends here from this picture because it's crushed. So it's at least 34 inches, possibly longer. It's massive.
That would
And
make
again,
it nearly a record-breaking Triceratops horn if it was a Triceratops horn.
it would be record breaking. Like that's rivaling Yoshi's trike, which is the biggest. And I think that's just over a meter.
Whereas it would be pretty normal for a bison latifrons.
Yeah. The second part is the curvature of the horn. This horn has a very strong curve, which we see better in other images, follows the entire length. It doesn't curve and then straighten out. It doesn't curve and then recurve. It just curves, which is more consistent with bison latifrons than either species of Triceratops. Third,
This is
what's
compelling.
okay.
Thank you.
Oh, well, I'm glad to hear it. For the third point, I do actually have one of the better quality images from the interview here. You can see there are parallel grooves following the length of the horn. They're not continuous, and the horn itself is kind of in rough shape, but these grooves seem to follow a lot of the horn.
And also, one thing I
And
want to point out about this, because it's
Here
our
is
best
it
picture.
next to a bison latifrons for comparison. Go ahead. Sorry.
The thing I want to point out is you can actually see plant roots invading the fossil here, and that'll become relevant later. Is that we actually have these little sticky bits? Those are plant roots that are, according to Mark, were in the fossil. So we can actually see those, and that will become very relevant. I do want to say thank you to everyone who has super chatted and gifted memberships. We will be reading all those out towards the end. I just want to repeat that because I have had a few people who weren't here at the very beginning who thought that their super chats would be read immediately. So we are holding them towards the end. We'll be doing a check-in with Will to see what questions he has, and then we'll be opening it up to everything that we have had super chatted, provided, like I said, that it's polite and on topic. You say, Will, you're just a jerk.
Hey.
We're not going to read it.
Send in all your dinosaur questions. I love answering those.
There you go. All right.
And lastly, our fourth point here, which is a big point for me personally, is what of the base of the horn we can see seems to be an extension of underlying bone rather than the horn emerging directly from a massive bony shelf like we see in Triceratops. And like you can just see here, this shape here looks a lot like the bison latifrons because it has that extension. Whereas the Triceratops, you'd expect to just see basically a shelf of bone running in this direction. But that is my opinion from reading papers and looking at all this stuff. But I didn't just want to give my opinion. I reached out to a friend of mine who studies ceratopsians. And before I read what he says, I will say, I'm aware expert testimony can be faulty, but he is more familiar with ceratopsians than I am, so I wanted to ask him about it.
Actually, I do want to say one real quick thing, which is in Mark's favor, actually. It is the case that if this is a bison latifrons horn, it would be the first bison find on Bice Ranch as far as fossils go. So that would, in fact, make it somewhat unusual for that. And it is known to have produced numerous Triceratops fossils. So it is not crazy for anyone to say, oh, I found this horn that looks kind of like a Triceratops horn in a place where Triceratops have been found before and say that it's Triceratops, which is one of the reasons I don't think Mark is lying. Because, like I said, this would be a unique find for Bice Ranch, but we also know that Bice Ranch has Pleistocene rock, which is where we find bison latifrons, and that bison latifrons has been confirmed to be found not there, but a few miles away, which means it's in the region where we might expect. So, like I said, I don't think Mark is lying about this. I think he's sincerely mistaken.
Yes. And I agree. It would be unusual for Bice Ranch, but Bice Ranch exists in an area known for both Triceratops and bison latifrons. He did his master's thesis on ceratopsian horn evolution and methods of combat, which he should be getting published soon, which I'm really excited to share around. But according to him, the curvature of the horn combined with the sheer length greatly resembles that of B. latifrons. But this does come with the caveat that Triceratops horns have a great deal of individual variability. The bones at the base also resemble the outgrowth bison have on their frontals. And Will, if you would like to reach out and ask him about this directly, he said I could share his email to you,
Okay,
just not
great.
publicly.
Thank you.
Yeah. But yeah, I find it more likely that it is bison latifrons based on all of these criteria. As far as I know, so does Dapper, so does my friend. It's just a lot of this stuff is more consistent with a bison.
I have two thoughts. As you
Yes,
guys
sir.
probably will either already know or will come to know, I love to solve problems as quickly as possible. So my first thought here is, you know, there's always two sides to every story. So I don't know if I'll ever get Mark's side, but this part here is compelling to me with the pictures, the lengths, all of that. To me, the best solution seems to be I don't know whatever test he did, but to do that on a Triceratops skull that has horns attached versus a horn that's by itself. Why don't we, like, I'll pay for it. Why don't we just do that?
I mean, I would be fine if, as long as the museum that has the Triceratops is okay with the test being done.
Mhm.
And like, yeah, sure.
Okay.
You might want to be
mean,
very select. Oh,
genuinely,
sorry.
genuinely, reach out to the Museum of the Rockies. They have dozens of Triceratops. Say, hey, I want to sponsor some research on Triceratops soft tissue. Can you help me?
Yeah,
Yeah.
If you're
they'll
gonna
probably
pay
say
them,
yes.
they will do it.
I'll just say
Mhm.
be very careful to get the best like most intact preserved horn that you can, because the more weathered it is, the more likely that you'll have contamination that will be hard to get rid of. So like, you want to be very picky about which Triceratops. But yeah, if you want to do this, I would say go for it. I would love to see it
I'll,
done.
I'll try to involve you guys. I won't do it behind your back.
Even if you did,
That'd be
I'd still be
awesome.
jazzed about it. I'd just be like, this is cool science. Because like, I mean,
Yeah.
sure, I would love to be acknowledged there, but like, I just really like cool science, and it would be cool science regardless of my involvement.
I
Yeah.
will never complain about a new paper getting published as long as it's up to scratch. I will
For
never
sure.
complain.
Yeah, like in a perfect world, I would want to go find a Triceratops
That's harder.
and yeah, exactly, and know it's a
What?
Triceratops, and then
It's not that
stop,
hard. Yeah.
and then call you guys and have you guys come help me excavate it so that it's all above board. You guys know exactly where it is. You help me excavate it, and then doing the test as quickly as possible. That would be in a perfect
I mean,
world.
that would be
I
super cool, and I would love to be involved in that to the maximum extent that I can. Yeah.
I'd love to come along, but I would I would insist that the
Uh-oh.
bones be sent to and reposited at a museum for further
Oh, yeah,
studies.
no, I would agree that it would not be
Yeah,
Right?
any of our private ownership of the bone.
yeah. I
Yeah.
mean, heck, you can talk to Bice Ranch and the MOR, see if you can set up something. Because they do
Okay.
have Triceratops there.
They do.
And they will let you go look for fossils there.
They have enough Triceratops there that they can advertise that as a thing that you can go look for and do it profitably and have people actually successfully find Triceratops. Because Bice Ranch is actually a really good fossil site. And when I say I object to like the private fossil trade, what I don't object to is landowners charging entry fees for you to go dig around on their land, because that seems eminently reasonable to me. I just would prefer that afterwards that thing be owned by a museum, some kind of like public institution where it is available for study. Because some of the
For
biggest
sure.
tragedies are that some of the best dinosaur skeletons that we know of just can't really be studied. Actually, one of them is owned by Answers in Genesis. Ebenezer is their name for I believe, an Allosaurus that they have, which is one of the most complete Allosauruses ever found. But no one's published any papers on it because it's in a museum case in a private museum that doesn't really let people just take all the measurements they want, which kind of sucks.
I had no
Um,
idea.
I would not say that we need to take it away from the Creation Museum, which is where it is, but at least make it so that it's publicly available to paleontologists. But I'm not Ken Ham.
Yeah. Yeah, that all makes sense. So I am gonna try to make this happen.
That'd be awesome.
That'd be
Um,
great.
yeah, just give me a little bit of time.
Obviously, yeah. This is not
Sure.
something you've set up in an afternoon.
Yeah, I'll keep you informed with any progress I make. If you haven't heard from me in a while, feel free to reach out. It's all good.
All right.
Sounds great. Well, so that is our case for this horn most likely being a bison latifrons. I did have I did do a bit of detective work in preparation for this, and actually a few years ago, I think that some of the location information given by Armitage is kind of funky, let's say, given some pictures that did come out after the paper was published. But if you're not interested in that stuff, we don't have to go into it.
Yeah, let's skip ahead to the he actually found, because there's also some questions about the techniques that he used to recover. Well, you've seen it's all over the place as far as I can tell. But then again, I watch an absurd amount of creationist stuff, so maybe I'm weird. But have you seen the bit where there's this sheet of brownish material that is stretched with some pliers? Okay, maybe you haven't seen as much creationist stuff.
It's funny. I watch debunkers mostly.
Okay,
I will be right back. Sorry.
Okay, I probably watch like 8 or 9 hours of creationist material a week.
Wow.
And most of it I end up not doing anything with, and the big reason isn't because it's necessarily particularly bad or particularly good. It's just boring. And I don't want to subject anyone else to it, so I'll find someone else who's making the same points, but in a more perhaps charismatic way. So,
Makes sense.
And actually that's something you brought up while we're waiting for Doc, about Carl Werner. That's one of the reasons I haven't really talked about Carl Werner directly, like reading from his book, because I find people don't generally want to hear me read a book and then respond to the book as I go, even though I would love to do that because it would open up a whole lot more stuff. So what I'm actually thinking about is trying to figure out a way to make that compelling. And so I don't know what that's going to be, but I would love to, because there are definitely books that I would like to respond to, and Carl Werner is one of the authors of such books. So welcome back, Doc. Let's plow through with this, because, like I said, we don't want to make this a 5-hour trip.
Sure. And sorry about that. My little
right.
sister's outside. She was knocking on my window.
I hope she's okay.
Oh, she's fine. All right, so I have some problems with what exactly Armitage says he found in these bones. Because in his initial publication and in others, he's claimed to find blood vessels, cells, nerves, and a bunch of other biomolecules, all of which he says is from this horn and the associated bones. So the ribs, the vertebrae, stuff like that. Now, to be clear, finding bits and pieces of these things is possible, as demonstrated by the work of Dr. Mary Schweitzer and others. But some of his claims are a little less credible. For example, he says he's discovered blood clots in the Triceratops bones, which, if you look at this picture here, or these pictures here, these are just mineral incrustations.
Yeah. They're not obviously blood clots in any significant way. Although I will say, it is very cool that you got such nice pictures, because again, the microscopy work is great.
Yeah. But these are just minerals that are, granted, within what might be a vessel, and that's cool. But they're just minerals.
One of the ways
these
you can
are
tell,
just mineral incrustations on bone.
One of the ways you can tell is that mineral crystals usually have a particular like geometric arrangement of the crystal lattice, which is reflected in the large scale crystal. And what you can see here are a lot of repeated the same angle from different crystals, whereas blood clots are just a web of relatively small proteins that bunch together in a haphazard way. And so if it were a blood clot, it would more likely look like, like cobwebs from like 2 centuries worth of cobweb buildup. Whereas this has a bunch of right angles going through, which makes it it makes it basically unarguable that this is in fact a mineral accumulation of some kind of crystal.
Yeah. And these are under, it's not polarized light, but doing some kind of light work with microscopy, because he is a microscopist. But we're just looking at minerals that are growing on the sides of bone pieces, which that is a fossil.
Right. Fossils are just
that
bones that have
grade
turned
school
into
definition
stone.
of fossil. So yeah, he claims he's found blood clots. But there's another issue with what Mr. Armitage did to find these things in his bones. Because according to the publication, once the bones were obtained, Armitage and Anderson took them to a lab and soaked them in a solution of glutaraldehyde with a buffer for 5 days. The samples were then rinsed with distilled water before being broken into smaller pieces for examination.
And that step right
Some
there
of
is
these
why we don't have the horn available, which isn't necessarily a terrible thing, but it does mean that we can't just grab the horn and check it.
Yeah. And some of these fragments were decalcified, and any soft tissue scraps were infiltrated with resin. That process sounds pretty simple. Until you know what glutaraldehyde does to organic material. It is a cross-linking agent. A very reactive cross-linking agent, for the record. And Armitage and Anderson added a solution of glutaraldehyde to a specimen they had not previously cleaned.
Right. Which means anything on there, like bacteria or those plant roots that we found, are going to start to dissolve a bit and then stick together into a kind of sludge that is going to pervade the fossil. Which means if there's any contamination on it, what you're going to find is that you're going to have a soft sludge that is going to be probably in sheets, because fossils tend to come with little layers in them, which is, as we'll see, what Armitage found, which is exactly what you would expect if you just soaked something you dug out of the ground full of things like insect bits and plant roots and bacteria in glutaraldehyde before first cleaning it.
Yes. Quoting from a 2016 publication by Armitage about this specific horn, he says this about its preservation. It was infiltrated with plant roots, fungal hyphae, and insect remains
And importantly, transversing.
throughout the horn.
Yeah, that's what that transversing means. It doesn't mean it was just on the surface. It means it was going through. And in case anyone doesn't know out there in the audience, fungal hyphae are kind of like roots. They're little strand-like projections. That is actually most of what a fungus is when it's living underground, which is what it does most of the time. And they go in and basically dissolve things near them and digest that. It's how the fungus feeds, and it's also the bulk of what a fungus is. But conceptually, it's very similar to a root in terms of like, it just grows in branching patterns like that and can infiltrate into things. And hyphae are often as thin as one cell, which means they can infiltrate tiny, tiny crevices like you might find in a horn that had weathered out of a hillside.
That is covered in stuff. And that's not even mentioning, that's not even highlighting the insect remains and likely insect feces, both of which would be materials ripe for cross-linking. And just as a reminder, soaking this stuff with
Glutaraldehyde.
It's a hard word to say.
It is a hard word.
Glutaraldehyde was the first thing they did. When you want to do microscopy work on like fossils, like in a normal publication, you thoroughly clean them first and isolate what you want to study as best you can. You don't throw the whole bone in a bath.
Well, to be fair, they threw small
Unless
pieces
you're just
of
doing
bone.
it to see what comes out. But normally you don't do that.
Yeah.
Especially not in a cross-linking agent when you're looking for things like proteins and stuff, because you will create them.
To be clear, is the issue here order of operations, or he should not have used glutaraldehyde at all?
It's primarily order of operations, but glutaraldehyde is not normally the chemical that is used for this, as far as I can tell from having looked into it. Usually what's used is just a weak acid to remove any minerals, and then checking after that, which glutaraldehyde is not one of the simple weak acids. I believe, like when Mary Schweitzer found her initial find, I believe it was it dilute sulfuric acid or something like that?
I want to say yes, but I haven't read her publication in a bit.
Well, it was certainly not what this is, which is a fairly complex organic molecule that cross-links protein. Because I remember it being a fairly simple acid, but that's the normal step. So glutaraldehyde is a weird thing to use, but I wouldn't say on its own it negates his finds, but because he used it first before the cleaning, all we have now is just everything that was in there has been turned into a bit of a sludge whose shape is defined by a sticky sludge, whose shape is going to be defined by the negative space within the fossil.
Yeah.
Okay.
So, yeah, you clean your fossils first. He did not.
Nope.
Bad things. And like this glutaraldehyde, It's used in like tanning. It's used in a bunch of applications.
Which is you want cross-linking, right? Because if you just have some cow
If
skin,
you're
it's going to
studying
rot.
like tissues, yes,
Well, I'm talking about
to
tanning,
help
yeah.
keep the tissues together.
Yeah, cross-linking is also what formaldehyde does, right? Like if you ever, I don't know if you ever dissected a frog in school or anything. I did, and our frogs, we didn't get them live. We got them preserved in formaldehyde, which is a very distinct smell if you've ever smelled it. And what formaldehyde can do, also what iron can do, what glutaraldehyde can do, is it can take organic molecules like proteins. And normally they form along a chain, right? And the big links are along that chain, but it can cross them over, they can fold over on themselves and then kind of be glued together chemically by this cross-linking agent, which makes them both more resilient in terms of just mechanically more resilient, which is why leather is more resilient than just raw cow skin, right? Because it's cross-linked. But it also makes it so that they don't decay as fast, because the way that decay happens basically is things, either natural processes or organisms, go in and break down molecules. But when they're cross-linked, they're less likely to break down because they have fewer exposed sites where chemical interactions can come happen. And so they become both mechanically and chemically resilient.
Mm-hmm.
Okay.
Yeah. All this to say, he basically created soft tissue, in air quotes, in the fossil by doing this.
And again, I don't think
just
that was
from all the organic matter.
I don't think that was him trying to fool anyone. I think that was him not being familiar with the standard procedure.
Mm-hmm.
Yeah, it was a consequence of his methods. And yeah, again, since they did it before cleaning it, I'm not surprised that they got something like
if you could mute
this.
that
Now,
for me.
Mark then was able.
Thank you. I just don't want any problems with copyright. This is actually that footage that I was mentioning earlier, Will.
Wow.
This is from Mark, and this is what he found in the horn. And I will not dispute that that's what he found, but that's also the kind of thing we might expect if you soaked a uncleaned horn in glutaraldehyde for several days.
Yeah, or just a chunk of dirt, to be honest. You'd get stuff like this in it.
Honestly, yeah. A chunk of dirt would probably do the same thing.
Yeah. Oop. So, yeah, it's...
The only stretchy
Not
video
your
I've ever
podcast.
seen like that is from Mary Schweitzer.
Yeah, she had another one. And hers, one thing you can tell about hers is it's smaller. For instance, it had to be backlit, which is why it's kind of see-through. And with this is a macroscopic chunk of something. And
yeah, these are tweezers.
yeah, and you can tell that actually,
on.
even just looking at it, right, it has a lot of heterogeneity. And that's probably because it's made of a bunch of different things. It's probably not all one thing. Whereas if you look at the Mary Schweitzer video, while it's chunky, the entire thing looks like it's made of the same stuff. Which is probably because it is made of the same stuff for Mary's work, because she just used an acid that wasn't going to combine otherwise uncombined organic material.
Whereas with this, you can see stuff embedded in it as it stretches.
Yep.
Okay.
Okay.
I've seen that footage so many damn times; it's burned into my brain at this point.
And also, well, so this is from something we kind of skipped earlier, but we were talking about, were these bones found where Armitage said they were? There are a few things from media we've gotten after the paper that lead me to doubt some of his claims about their provenance. This photo of them in a dry stream bed is one of them, because this looks like the area around Bice Ranch. You can see hills in the background. Those are probably Hell Creek. But this photo is taken pretty far down in a dry stream bed. And I can say that with some certainty because I've spent a lot of times walking through these kinds of stream beds looking for fossils.
Yep. And what are the stream beds they're made of?
Cutting through the... Sorry?
I said, oh, sorry, you were just getting there.
Well, all of the streams cutting through this area are cutting through Pleistocene sediments, where you would get bison remains.
Yep. Where we found
along with other Ice Age mammals.
That other bison horn that was found nearby was found in Pleistocene alluvium, which is the kind of rock that you're looking at here in that cutaway.
Sorry, guys. What age are we talking for Pleistocene?
So this would be last Ice Age. So tens of thousands. We're talking like 30, 40,000.
All right. This will show my ignorance. How is the higher land tens of millions of years old and the lower land here tens of thousands.
Sure. So you have, sediments they pile up, and then they squeeze down to form rocks, right? And this continues happening, and you get more sediments turning into rock. However, if you get a lot of water passing through an area, for example, the rate of erosion can go faster than the rate of deposition. And the water will carve a valley into those sediments and rocks. If the sediment supply to that river increases, the bottom of the river will rise up and deposit stuff in its own bed.
That's newer.
Yes, that's newer than the stuff to either side.
Yep.
So you have a little valley filled with new material surrounded by old material.
Yep. And then higher up where the river wasn't, or that might have just had harder rock, you can get older rock that is preserved there. So for instance, like if I just dug through a big part, like if I just dug my own Grand Canyon and then filled it up with dirt, there would be a bunch of brand new dirt sitting next to a bunch of really old rock. Which actually, interestingly enough, does actually happen in the Grand Canyon. There's something called Surprise Canyon, where there's actually a Paleo Canyon that's preserved in the Grand Canyon, where you can see the rock from newer ages filling in an ancient canyon that's cut through by the Grand Canyon. And we've done like scans with like, seismic scans and things like that in the rock around. And we've actually found that Paleo Canyon called Surprise Canyon has its own barbs and tributaries. It was a full-on canyon that's preserved inside the Grand Canyon, which I think is one of the coolest things in geology.
Here, so for like a picture example, let's say these hills are made up of older rock. A stream has come down and cut between them to form this valley. If the sediment supply to the stream increases, the stream will start to deposit sand in its bottom. And then later on, the same stream can cut back through the sand it deposited. This is a sand deposit from the Ice Age, surrounded by older rock.
It's also not even really fully rock. It's a lot of it is still relatively loose. Now, the part that Armitage went through seems to have been hard rock, which some of this is also. And I say that because he reports having to work really hard with like chisels and hammers and whatnot to free the horn. And I don't see any reason he's lying about that. Although one interesting thing, well, maybe he is lying. I don't know. One interesting thing though is he also
I'm not
claims
saying he's lying. It's just sediments can be very compacted.
that's true.
So
Another interesting thing though is there was actually a interview he gave where he said that he had part of the bone carbon dated, which is a weird thing to do. But he also said that it came back as like 38,000 years old, which if he's accurate and that's what happened and it was a good sample, that also just puts it right in the conventional range for bison ladder prawns, which like okay, cool, Mark, thank you.
Yeah.
And I can send you the interview. It was done with an organization I'm actually not familiar with, so it was the first time I seen it was actually just today because I wanted to brush up on my my Armitage lore, if you will.
There's a bit of a catalog. The man's been busy since 2013.
Which, hey, I mean, good for him. I'd rather that people be busy doing stuff than just sitting around doing nothing.
Yeah. Let's see, I had this. And then just kind of an overview of the outcome of Armitage's research. Since Armitage and Anderson's publication in 2013, many young Earth creationists have used his research, along with other research by Mary Schweitzer and others, to support their belief that the Earth just can't be ancient because the soft tissue is preserved. If it is soft tissue, depends on the paper you're reading. Many researchers have spoken out against their research being used like this, including Dr. Schweitzer herself.
Who is also, I want to point out, an evangelical Christian who is a former young Earth creationist.
Yes. And she was asked about this in a 2014 interview with BioLogos, and I'll just read her response quick. One thing that does bother me, though, is that young Earth creationists take my research and use it for their own message. And I think they're misleading people about it. Pastors and evangelists who are in a position of leadership are doubly responsible for checking facts and getting things right. But they have misquoted me and misrepresented the data.
So if someone's misquoting her, that's wrong. If they're misrepresenting the data, that's wrong. But using someone's research for their own message there's nothing wrong with that, in my opinion.
On its own. Although I
Mhm.
think what she would probably say if she were here, not that I want to speak for her, is that because they are using it to come to conclusions that both she and her colleagues do not find anywhere in the data, that doing so is misrepresenting their data and saying it leads to this conclusion when everyone who's working on it says no, it doesn't, and also have what I consider at least quite compelling reasons why it doesn't that are
To me, that's how science works, though. There are scientists who oppose her research. That to this day, they're like, we don't think this stuff can last for as long as it has. So
And
So
they're disagreeing with
there,
her conclusion.
so there are a few. The field has very much come to accept her research just
Mhm.
as a
'Cause she's done
consensus.
such a good job.
oh yeah, she has.
Yeah, like, I do not know any paleontologist in my generation who doesn't appreciate Mary Schweitzer's work
Mhm. Yeah,
and the information she brought to revolutionize our field. Like, a lot of us are doing research that wouldn't be possible without her work in some way or another.
definitely. Yeah,
She's
I actually
very
consider
received.
her discovery the greatest find in the last century, personally.
It's definitely one of them. It was I don't want to rank discoveries because
Yeah.
I know there's personal bias in there, but it's up there for sure.
At least in
Yeah.
paleontology, it's certainly one of the
Awesome.
most important ones recently.
And then,
and I'll say this
to
about young
broaden
Earth
the discussion a little bit,
real
because we've
quick.
been focused on Armitage, his work,
Oh.
and stuff like that. I wanted to take a minute to maybe talk about some common misconceptions that creationists have with paleontology and fossils that I think
Hey Doc, real quick, can you
might
hear me?
lead. Yeah,
Okay, sorry. StreamYard switched to a different microphone, and it was a microphone that's not actually active. So sorry, I just wanted to make sure.
okay. No, can hear you. But I just wanted to talk about a few things that I think creationists often get hung up on that makes them more incredulous of the science. So, for example, the Earth can't be old because we find this thing in fossils. And this can be collagen.
Oh, hey, Will only
protein.
has about 25 minutes, so why don't we cut to the Q&A, and like just read off what's on the slide real quick, as fast as you can, and then we'll close that out with questions, and then we'll go to the super chats.
Sure. I'll zoom through.
Okay.
Basically, a lot of people have a very simplified idea of fossil formation, and I think a lot of misconceptions stem from that make people incredulous of paleontology in general. It's more complicated than a lot of people learned in middle school, is basically what it boils down to. And Dr. Schweitzer's work has been a big part of showing us that it's more complicated.
Yeah.
A lot of people are just still beholden to that middle school idea of how it works. They don't know the advancements we've made. For example, we can do stable isotope analyses. We can analyze the atoms within a fossil if it's preserved well enough to uncover clues about a dinosaur's life. These are charts showing the body temperatures of different groups of dinosaurs from isotopes in their teeth and eggshells.
Which is just crazy.
It's really crazy. Or for this study on Ao Confuciusornis, an
Which
early
I
bird
think
relative.
we covered that last time, so I think Will is already familiar with that particular. Actually, that particular specimen was there yesterday. So why don't we
Maybe.
continue on there? No, it definitely was. I remember it.
I'll just say there's been like this has keratin in it, which is like original keratin. That's really cool. And collagen too. We understand broadly how these things preserve now, or at least we have competing hypotheses, which is a good thing in science because it helps you get funding. But we have
also
ideas
helps us
of how
learn.
these things work. Yeah, it helps us learn.
All right, we got to rush through. We got 2 more slides. All right.
Yeah, we can go to the Q&A.
Will, so first, do you have any lingering questions from what you saw that we can clear up?
No, I think you guys made a good case.
Okay.
I'm open to the fact that it's definitely, a bison horn. Like I said, I love to get to the heart of the matter, and to me, something that's been destroyed, we're not going to really get anywhere with that. So I give you my word. I'm going to try to find something that is in the skull that we can do a test on.
Awesome. Actually,
That'd
you're
be
more
awesome.
confident that it's a bison horn than I am. I'm only about like 80% sure that it's a bison horn.
I'm just open. I'm open to the possibility based on the presentation.
All right. So
I consider that a victory. Thank
We'll-
you, sir.
we'll go to chat.
Thank you.
Joshua Geese who gifted 5 memberships. Thank you very much. Petite Flower for $5 says, are we going to talk about how new research isn't truly accepted as science unless it can be reliably replicated? And I think we did. We talked about how, like, the first time that something's done, yeah, you publish on it and no one's replicated it. But for it to become a big part of, like, the consensus, it has to people have to be able to replicate that study. And I don't know, Will, do you have any thoughts on replicability?
Not really. There's going to be weird circumstances where you can't, like, we can't go get moon rocks from where they got moon rocks, but
Not yet.
no, I think repeatability is a good thing when you can do it.
Okay. Sylvan Epiglottal Stop for 100 Argentinian pesos says, if you found some bones in the ground, I guess this is a way to know if they're dinosaur. This is how you decide. I'm sorry. That was directed at my question to Kent Hovind years ago when we debated whether or not birds are dinosaurs. And he revealed that he didn't know what a dinosaur was in the first place, which is a weird position to take when you are trying to debate if something else is a dinosaur.
Yes,
And call
for
yourself
anyone
Dr.
curious,
Yeah.
my moniker is a parody of his. And also, one of the
figured.
first videos I ever made on YouTube was of that exchange with Kent. It was a meme.
I debated him because when I grew up, he was a not major, but a significant part of my church experience. Admiral Snappy Turtle sends an 8-month super chat that says, we need to rub some pelagic tunicates on these guys to start using basic reasoning skills. Thank you. That sounds like a horrible crime, though. And I will, if you did that, I would turn you into, I don't know, Interpol? I don't know who was in charge of pelagic tunicate-related crimes. Lieutenant Math Navigator for $5 says, that T-Rex femur is on display, or at least it was in the MOR.
Yes,
Let's see.
I think it's MOR 555. It's either 555 or 1125, one of them.
Which means,
also,
hey, you can go see the famous Mary Schweitzer. Oh, what do we got?
Cool.
Nice.
let's see if anyone can figure out who this guy is by the time the stream's over. Just see if anyone can figure it out through super chats.
Can you raise it a little bit? I think it's some of its teeth are covered. There we go.
Yes.
Awesome.
He's got
Naranda
a
puts for
tail
$5. Where a find was found conveys important information. Fail to document it, and you permanently destroy part of the find. Sorry. That is true. That is one of the reasons why the Ica stones, or the Ica stones, depending on your pronunciation, were never really accepted by the archaeological community, is because basically some guy said they came from a cave that he won't tell you about, which is like, okay, well, great. Sapphire.
Wait, hold on.
Sorry.
What are those stones?
The Ica stones. So there's some stones from Peru, and they depict dinosaurs and UFOs and brain surgery and people riding dinosaurs. And at first they were just like, okay, well, these are just coming from nowhere. So like Peru is not specific enough. So everyone's just like, well, until we can figure out if these are even artifacts, no one cares. And then it turns out that the guy who was faking them just confessed. He was like, no, I carved these in my spare time, and then I bake them in cow dung to make them look old, and then I sell them to tourists. It might have been chicken dung. And then I sell them because it's a better living than farming, which, hey, you know what? Poor Peruvian farmer, more power to you. Like when you're on starvation level of like subsistence farming and like fooling some gringo tourist is going to give you a better life, whatever, go for it. I don't even care. That guy who bought that rock is not being seriously harmed, whereas you're having your life vastly improved. Let's see. Sapphire, Big Swamp Denier. Sorry. Big Swamp Denier Light has gifted 5 memberships. Thank you very much. Azaria for $1.99 says, Dapper is a jerk. Heart emoji. Thank you very much, Azaria. It's true. I am a jerk. I might be the biggest jerk. Let's see. Sylvan Epiglottal Stop for 100 Argentinian peso says, Dapper after finding a fossil. This belongs in a museum. Giant Ball starts rolling his way. Yeah, that's dangerous. Sinar is
Indiana Jones is not a good archaeologist for the record.
No,
Just
he
wanna
is
say
not.
that.
In Kingdom of the Crystal Skull, he just kills the locals who are in fact the owners and current inhabitants of his archaeological dig site. That's totally not okay. They were in the right. Sinar Izu, who's been a member for 19 months, is at the tetrapod level, says, the dino returns. I'm always here. I stream like 2 times a week minimum. Metageeky Platypus Librarian for $5 says, Doc, assuming it was a Triceratops, would a new dig be worthwhile? And if yes, would your peers be willing to work with Armitage on a collaboration if funded?
So I will always say yes to getting more fossils in museums. I would love to go out there and dig at the exact spot those bones were found and see if there's more there.
Mhm.
But from what I've heard, I'm not sure if I would want to work with Armitage. We would have to see.
Yeah, I wasn't planning to bring this up, but everything I've heard from people who've met Armitage, whether third hand or second hand, including from Shauna Beisch, says that he's an extremely unpleasant person to work with, and that is why he and his co-authors have since Kevin Anderson, have since fallen out, and that seems to happen with everyone he works with. So I would say I would be okay if he were in the periphery and I didn't have to interact much with him personally. But apparently, he's an extremely abrasive person, which that doesn't affect the quality of his work.
Unrelated to his research.
Yeah, you can be an absolute dick and have great science, and you can be the biggest sweetie in the world and have terrible science. Let's see.
That corner exists.
Thank you for reminding me. Jeez, that guy. Petite Flower for $5 says, the reason why Schweitzer's work is accepted now is because a bunch of other people replicated her methods and got the same results, which, by the way, includes Brian Thomas, the scientist from the Institute for Creation Research, which is one of the things I want to point out. It is not the case that young Earth creationists can't get published. They can. They are allowed to publish, and if they do good work and it passes peer review, it will be published. So, yeah. Naramda puts for $2 says, does Will Duffy know what quote mining is? I'm assuming yes, but Will, do you know what quote mining is?
Yep.
Okay.
People like to throw that out, but it's like, I don't know. A lot of times it's not.
I have seen people quote mine. I have not noticed you do it specifically. So I'm not going to say that you are someone who has quote mined. I have also seen people pull out a quote mine that they did not know was a quote mine and then not do the due diligence of checking, which is not the same thing as creating the quote mine in the first place. It's not great. Lieutenant Mathanav, which also, as far as I know, I haven't seen Will do. But then again, it's not like I watch everything Will does, so I don't know. Maybe Will is secretly going into the back room in his office and like digging through books to find dishonest quotes, and I just never notice. I doubt it, but maybe. Lieutenant Math Navigator for $5 says, we really are in a second dinosaur renaissance. I think that's probably true. Will, do you know what the dinosaur renaissance was?
No.
So in the 1980s, there were a lot of finds of new, especially like Cretaceous theropods that started challenging our ideas about dinosaurs basically being funky, slow, dim-witted lizards, and started to make us think that
one of them.
Yep, Deinonychus was basically the one that was the biggest part of the dinosaur renaissance. And actually, the portrayal of dinosaurs in the first Jurassic Park film is actually a direct response to the dinosaur renaissance and trying to bring that forward into popular media with the fast-running velociraptors and the T-Rex that's stomping around and running down quick, fleet-footed Gallimimus and things like that. Obviously, now, most of those reconstructions are pretty out of date. But still, for the time, I like to say that Jurassic Park brought the cutting-edge paleontology of the late 80s to audiences of the early 90s, which is basically what it did, with a few exceptions that were made for artistic license.
That does remind me. In your discussion with Erica last night, like you were asking why the raptors in Jurassic Park don't have feathers. There are a couple a couple of reasons for that. The first is we didn't know to what extent dinosaurs did have feathers back in the 80s and 90s when Jurassic Park was being made. We didn't know. And the second part is technological limitations. Apparently, Spielberg tried it, but he couldn't get it to look good, especially with like the scary scenes they wanted to do. So they went with the more leathery, scaly look instead.
I will tell you this, as someone who has made CGI dinosaurs several times, feathers are a huge pain, and I hate putting them in CGI dinosaurs. I know of someone who's actually a paleo artist I follow, and she does amazing work. But also, one of the things you'll notice is that she very rarely animates anything, because while she can put feathers on a static mesh pretty easily and fix them after she poses the mesh, in animation, they're an even bigger nightmare. They clip through each other all the time. They don't interact well. It's a nightmare. Fur is easier. And
Yeah.
that's one of the reasons why I don't generally make feathered dinosaurs because it's a pain. Let's see. We got Fear Floating Rocks Monger for $5 says, Will, would you accept if someone showed you Jesus' bones but didn't properly document where they found them or show they're not from some random dude? So I think basically, like, would you accept some bones that someone claimed were Jesus' bones as Jesus' bones if they weren't given provenance, like we were talking about earlier?
It's a really good question. I would need to know why they're claiming they're Jesus bones. We have a very interesting thing with the Shroud of Turin. I don't think we know where that came from originally, but it's still super fascinating. So if there was evidence in addition to where it came from, if that was unknown or being withheld, I guess I'm open.
Wouldn't I guess it's not super on topic, although I would expect you to be extremely skeptical of claims of Jesus' bones because such things shouldn't be found, right? Like,
Mhm. Well, that's a good point.
yeah.
Yes.
Um, maybe what if someone said they found it in some back alcove of the tomb of the Holy Sepulchre in Jerusalem?
Okay, sorry. I misunderstood the question.
Oh, okay.
Yeah, sorry. I was going down a different angle of I was likening it to Mark, right? Which is he's claiming he found something, but he won't say where it was from.
Yeah, yeah.
So I think what they're saying is like, what if they claimed something that you don't believe exists was
Mhm.
found, and they were unwilling to explain where it came from? Yeah, obviously that would cause a seed of doubt and uncertainty for sure.
I'll be honest, I would be very skeptical of anyone claiming that they found Jesus' bones, because to me, regardless of the truth of the resurrection, the chances of finding some guy's bones from the first century are just stupendously small, and then being able to figure out who it was, even smaller. So, like,
Mhm,
I would be like, no, I don't think you did. I
mhm.
really don't think you did. Although maybe if you found them in a place and they were labeled, I'd be like maybe 10% is as high as I'd go in terms of confidence that these are actually Jesus' bones. Which actually, we're caught up, and I just want to say one last thing about Jesus archaeology. I hate when Jesus mythicists say we don't have a single archaeological piece of like from Jesus' life, like we don't have a single sandal. It's like, I'm sorry, guy. How would you know if you found Jesus' sandal? Do you think he wrote his name on there like they were his
Right.
sneakers from when he was a kid? And even if they did, wouldn't stay there. And also, do you know how many Jesuses there were? What what would you expect to find in terms of archaeological remains of an itinerant preacher from the first century?
Yeah, you know what's interesting? I haven't looked into this, but I think it's possible we found Paul's bones.
I did
Is
hear
that
something about an
fascinating?
ossuary, and that would be very fascinating. And I'm definitely not a Paul mythicist or a Jesus mythicist for that matter. I think
Yeah.
most people who say that they didn't exist are they're on the crazy end.
Yeah, I
Um
would agree.
I actually had someone say, "Oh, you just don't know Richard Carrier's arguments," which was fair. I didn't. So I looked into it and I was like, "Oh, this is way dumber than I ever thought it was possible. This might be some of the dumbest things I've ever heard. This is complete nonsense." So yeah, that kind of backfired on that person when they were like, "Oh, you just have to check them out." But you know what? We are wrapping up here. Will has to get out of here. So first, I want to say, Will, thank you so much. If you have anything coming up that you want people to know about, please let us know so that people can go check that out. And yeah,
Yeah, no, thanks for having me. I'm gonna continue on my journey here with Erica. It's a lot of information.
it sure
It's
is.
it's actually a lot of work, but it's good. Learning is never a bad thing. And again, I'll keep you updated as I have progressions on my end. You can pass that along to your audience, and we'll see what we can do together here.
That'd be awesome. Donk, would you like to reveal what the plush is before we ask you what's up?
Sure. So, me and my mom found this at a dog toy store a couple months ago. This is like an 1800 style iguanodon
Oh,
as a
that's
dog
awesome.
toy.
That's awesome.
Yeah, I didn't believe it when I first saw it, but like the body shape matches. It's got the spikes on the back. It's got the horn.
The
It's
horn
an
that was actually a
iguanodon.
thumb.
Yeah,
Nice.
it's really cool.
All right, Doc, what
Cute.
do you have coming up that you want people to know about?
Uh, well, I'm working on a couple videos right now. I'm currently working my way through a review of the dinosaurs documentary on Netflix. And I'm starting to stream again every now and then. I might tonight. I'm going through one of my childhood games, Fossil Fighters, which
Nice.
is a really fun one.
Real quick, Sylvan Epiglottal Stop for 100 Argentinian pesos says, I'm pretty sure Ron Wyatt found Jesus' entire wardrobe signed Jesus F. Christ, but sadly lost it before he could store it in a museum. Yeah, that does sound like a Ron Wyatt find. I don't know if you're a big fan of Ron Wyatt, Will, but I am certainly not.
He's deceased, right?
Yes, as far as I know.
Yeah, he made a lot of claims. Unfortunately, he didn't really back a lot of them up. So it's just more of a disappointment than anything for me.
Yeah. I mean, a lot of those claims I'd be open to if he ever actually provided the evidence that he said he had. It was always like, oh, don't worry, the pictures are coming. Like, when, Ron? And then he died. And it's like, okay, so never. Got it. All right, what's going
Those
on?
arc ones, like, they're just raised rocks.
Yeah.
All
So
of
what's
them.
coming up for me tomorrow? Come check me out with the normal crew for a D&D actual play. It'll be session 2. That'll be over on Top Hats Off. The next day, I'm going to be back, and we are going to be taking a look at someone who says that the Old Testament was actually written in Greek, and that Hebrew is a made-up language that was invented by Greek scholars, which is as crazy as Will is making it seem. It is a completely bonkers idea. There is absolutely no good reason to think that. And many, many compelling reasons to think otherwise. So we're going to talk about that on Saturday. Then on Tuesday, I will be back with Jackson. We'll be taking a look at some more creationist stuff. And then next Thursday, I believe the final video about Jay Seegert will be up on the channel for a premiere at noon Pacific, 3 p.m. Eastern. So thank you very much to everyone who super chatted, everyone who was here. Make sure you hit like on the way out, and make sure you stay tuned over on Guts of Gibbon for Will's next discussion with Erica. Thank you very much, everybody. We're going to get out of here.
Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above.
Siloof, Ben Tovand, Tapioca Weasel, Mikau Dominiak, Sammy LaFleur, Edwin M., Kenneth Swenson, John Ackerman, Sphincter of Doom, Regios, Landon Knoll, Ian Chen, Eleron Teller, Phil Rivara, David Hercules, Joshua Geese, Dan Sheedy, Pegajace, The Plastic Mouse, Gordon Love Science, Amber Athelian, Prixie Purple, Agricola Sequa, and Me, Myself, and I.
It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 15% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos months before they come out for the general public. Thanks for watching.